Bismillahirrahmanirrahim. A theorem F is a subspace of a vector space V over the field F. Then prove that the linear combination, the linear spanning set spanned by the linear spanning set of the set S is equal to the linear spanning set of the set S. Since the linear spanning set of the set S is a subspace of the vector space V over the field F, then by a theorem which states that if S is a non-empty subset of the vector space V over the field F, then the linear spanning set of spanned by the set S is a subspace of the vector space V over the field F. Suppose that U belong to the U is an element of the spanning set spanned by the set S. Then by definition, U can be written as a linear combination of the element of the set set S, that is A1 V1, that is V1 V2 up to Vn are the element of the set S, and the set S is a subspace of the vector space V over the field F, and the linear combination of the element of the set S is equal to U. This element is an element of the linear span of S because the linear span of the set S is a subspace of the vector space V over the field F. Then the linear combination of any element of the set of this set is again belong to this set, and similarly this is a set, and the linear combination of this set is an element which can be written in the form of the linear combination of this element is also an element of the spanning set spanned by the set LS. As U belong to an element of the set S, also the element U is an element of the linear spanning set spanned by the linear spanning set of the set S. Therefore, the linear spanning set of the set spanned by the set S is contained in the set the linear spanning set spanned by the linear spanning set of the set S. That is, this set is a subset of this set. Conversely, suppose that U belong to the linear spanning set of the set spanned by the linear spanning set of the set S. Then by definition, the element U can be written as a linear combination of the element of this set. That is, V1, V2 up to An belong to this set, and A1, A2 up to An are any scalars. Since linear span of the set S is a subspace of the vector space V over the field F by an hypothesis as well as by this theorem. According to this theorem, therefore, V1, V2, and Vn are the element of this set, and this set is a subspace of the vector space V over the field F. Therefore, the linear combination of these elements, the linear combination of the element of this set is again an element of this set. That is, these elements are also an element of this set because this set is a subspace of the vector space V over the field F. That is, the linear combination of the element of this set is equal to U. That is, U contained in this set. As U is belong to this set, as well as it is proved that the element U is also an element of this set. Therefore, this set is a subset of this set. From equation number first, that is, the linear span of the set S is contained in this set, and this set is a subset of the linear span of S. Therefore, from equation first and second, the linear span of the linear spanning set of the set S is equal to the linear spanning set of the set S, which is our target.